All right, guys, we are back with our last special segment. So the last one is an altitude of a triangle, and the definition is it's the perpendicular segment connecting the vertex and the line containing the opposite side. Really love that definition, and there's a specific reason why. All right, but let me highlight some of the key things. So it says it's the perpendicular segment. All right, automatically we know what perpendicular means. All right, it has to connect a vertex. All right, but what I really like about this definition is actually that last phrase, which is the line containing the opposite side. Okay, so let me give you an example. So I'm actually going to draw two examples here. Okay, so the first one that I'm going to have you guys draw is an acute triangle. All right. And this is going to be the one that we're going to use, so you guys can go ahead and make that one kind of the focal one, okay? So we're going to draw an acute triangle, all right? And just try not to make it equilateral or isosceles, okay? So what we're going to do is let's go ahead and label actually these points just so it's easier to talk. So let's go ahead and label this bottom left point A. Let's go up to B. And then let's go down to C, okay? So if we're trying to draw the altitude from B down to AC, all right, and it has to be the perpendicular segment. So we're going to draw it so that it's coming down, all right, intersecting AC at a right angle. Okay, perfect. All right, now I'm going to go kind of rogue here for a second, all right, and you guys don't have to draw this, but just kind of follow along. So the reason why I wanted you guys to draw an acute triangle and the reason why I like this definition is for an example like this where we have an acute or an obtuse triangle, okay? So let's say, once again, that this is A, this is B, and this is C. And what if I wanted to draw the altitude coming down from A, all right? And the altitude, once again, has to be the perpendicular segment. But the issue with us drawing it to BC is that if we drew it to BC, none of these are going to be perpendicular, right? So that's why I really like this definition because, once again, definitions aren't just words slopped together. There's some significance behind it. So it's the line containing the opposite side. So if I extended, all right, whoopsie, that was not what I meant to do. If I extended, all right, BC out into the line that contains BC, okay, the only way that I could draw the altitude from A to now the line containing BC is if it was on the outside of that triangle. All right. So just kind of keep that in mind that sometimes your altitudes are going to be on the outside of the triangles. All right. And that's going to be specifically when the triangles are obtuse. All right. Now let's go back though to the acute triangle that we drew. Okay. And this time, we're going to now draw the other two altitudes, and I'm going to draw it from A to BC. All right, and once again, it's going to be the same kind of thing, guys. All right, where when we're drawing it, these three segments are going to intersect, all right, or they should intersect if you guys are drawing them accurately enough, all right, at one point. And that point is going to be our point of concurrency, okay? So that point of intersection or the point of concurrency, all right, for the altitudes are called the orthocenters. All right. Now I'm going to do a quick review, all right, of the special segments and the point of concurrencies and where they are in the triangles, okay? So stick with me for a second. So for perpendicular bisectors, our point of concurrency was the circumcenter. And we found out that the circumcenter is on the inside of the triangle. If it's acute, it's on the outside of the triangle if it's obtuse, and if it's on the triangle, if it's right, okay? We then went to angle bisectors, and the point of concurrency for angle bisectors are the incenters. And then the incenters are always on the inside of the triangle, all right? We then went to medians, all right? Point of concurrency was the centroid, and the centroid was always on the inside of the triangle. Orthocenters, and it should connect to the fact that we just saw that altitudes can be on the outside of the triangles, all right, whenever it's obtuse, is going to be the same as the circumcenter, where if it's acute, it's going to be on the inside, all right? If it's obtuse, it's going to be on the outside, and if it's right, it's going to be on it. All right. So inside, outside, on. All right, for the ortho center. Okay. All right. So we're actually going to skip over this next part. All right. And this concept inventory, what I'm going to do for you guys, all right, is rather than us kind of go through it right now, is I'm going to post my filled in, all right, example of this online. All right, so look for that, okay, so that it's just a really great way to study your vocab, all right. So we are going to do some of the vocab here, all right, or some of the application questions. So this question right now is asking us to decide which of the following special segments is represented in this picture, okay? So if we look at the first example, what we're given is that angle STV is congruent to angle UTV. So that means this angle is congruent to this angle. So what special segment do we have? We have an angle bisector. Okay. All right, going straight across. All right, we are given that UV is congruent to VW. All right. And so we're also given, well, that's it. All right, which means that V is our midpoint. All right, so what we have to decide right now is TV a median or is it a perpendicular bisector? Because both of them technically deal with midpoints, right? So I'm going to tell you that this is a median, and that's because we just have a lack of information, to be honest. All right. We don't know that these two segments are perpendicular. If it was perpendicular, then we would be talking about a perpendicular bisector. But because we're not given that, it's only a median. Okay. All right. For this one, for RT, we're given that it's perpendicular to SQ, which means that this is an altitude. Okay. And then our last one, we are given that angle CDF. Wow, that is not drawn to scale. All right, but we're given that it's a right angle. Okay. And we're also given that DE is congruent to CD. All right. Now, we're going off our given information, not our picture. All right. But what we have here is a perpendicular bisector. And that's because it is passing through the midpoint and it's perpendicular. Okay. So one thing that you guys should notice is different about a perpendicular bisector is it's the only one that doesn't have to come from the vertex. It's the only one. All right. So it doesn't have to come from vertex. So if you notice on that one's just kind of hanging out in the middle of the triangle. All right. And that's okay as long as it's perpendicular and it passes through the midpoint. Okay. All right. I'm going to pause there, and then I'm going to come through and do these next couple with you guys. I'm going to pick and choose, all right, some of the ones that I want to do. All right, but there's a really, really great question on this set. All right, so one more video, and then we'll finish up section 5.2.